So hello everyone, in this video we will solve another derivation from the model number 5 centrifugal pumps, which is known as minimum starting speed of centrifugal pump. So what should be the minimum starting speed of a centrifugal pump? There is a third derivation and very important one too. We'll try to solve this. So first let us understand, in order to have a complete working of a centrifugal pump, the suction line and entire casing must be filled with a fluid or water. If it is not there, then the transmission or the flow of the fluid will not occur. So as you all know, there should be complete fillment of that particular thing. And also, the overall power produced by the pump, the overall power produced or the head produced by the pump must be greater than the manometric head of the pump. So if the overall pressure difference or the overall head of a pump is greater than the manometric head, then only the flow is possible. Okay, so if the head produced by the pump is less than the manometric head, then the flow is not possible. Even you have to note that particular aspect as well. Okay, let us go into start. Now let the centrifugal pressure head for starting of the pump without flow, pressure head without flow be, as I told you, it is u2 square minus u1 square divided by 2g. Now, in order to flow happen, in order to commence the flow commences only when u2 square minus u1 square divided by 2g is greater than or equal to the manometric head. So this is the manometric head. Hm is what? The manometric head. Okay, so only when, if it is greater than Hm, the flow will occur. So you all guys know that U is nothing but pi dN by 60, which I am going to use now. So substituting in the above, it is half 2g, 1 by 2g into pi d2 square n divided by 60, its whole square. I'll just take square here. Okay, its whole square minus half 2g into pi d1 n divided by 60, its whole square. That should be greater than or equal to Hm. So this I would take it as equation number 1. Now next, you have learned that manometric efficiency eta m is given by G into Hm divided by U2 into VU2. Correct? From this, extracting Hm. What is Hm here? Hm is equals to eta efficiency into U2 VU2. This whole divided by only G is given me. Okay. Now substituting in above from 1. The same thing. Okay, I'll just copy this. Okay. So from 1, this would be equal to, substitute the value of Hm there. It is eta manometric efficiency into U2 VU2 divided by G. Okay. Now, for minimum starting speed, This has to be equal to, now your aim is to find n, no? So that is why you will equate this particular equation now. Okay. So same thing with an equal to sign in between. Same thing with an equal to sign in between. Again, I can even write this u2 as what? Pi d2 n divided by 60. So into 60, I'll write it here. Okay. Next. So what are the common things in these two? I will take it as pi square as common, n square to be common, divided by 2g into 60 square as common. So whatever is left, just write it here, d2 square minus d1 square is left, that is equal to pi n eta efficiency, manometric efficiency, into d2 into VU2, this whole divided by g into 60. Now whatever things get cancelled, I'll try to cancel those stuff now. This cancels, n cancels, pi cancels. Okay, so whatever is left, I'll just try to write it now. So it is equal to pi n divided by 2g into 60 into d2 square minus d1 square, that is equal to eta manometric into d2 VU2. Okay, now whatever n you have, n, so this is the minimum starting speed. So this is the minimum starting speed. Therefore, extracting n from the above equation, what you get, you keep only n is equal to nm, that is equal to 120 into eta manometric or eta m into d2 into VU2. In the denominator, you will be having pi into d2 square minus d1 square. So this is the expression which is required for this particular derivation, is the required expression for minimum starting speed of the pump. Okay.